Hey, how are you? I'm so glad to be here. I think it will be the first session, well, for a coach because Rosenda give the other pass too, for this ML, artificial intelligence slash week. So I'm super excited to see lots of people here. Really is amazing, and I see a lot of comments too. But first, I want to make sure you can hear me well and you can see me. Um, I know under good light conditions, but I think my face is recognizable, right? So yeah, nice to see you, Alberto. So I think yes, Pachuca Pachanga, nice, great comment. Yes, you look and sound amazing. Thank you. Let me start reading these comments because again, I think this is really really cool to have you all here. Um, Agneil033 says hello to everyone. Hello. Naps02 says hello. Shiva Del War so says hello. Road to K is the theoretical intro to ML happening. Yeah, we are actually getting to that. Anikani, I believe so. Hi all from Apollo. Um, Maybe in a few minutes. Yeah, I usually give 5 minutes to people to join us. So if this is your first MLH merely hacking stream, so let me welcome you and welcome to this thing we run almost every month, which is the Global Hack Week. Topic based week in which we select a topic. In this case, it's artificial intelligence and machine learning. And we run several streams trying to teach you the topic. Um, we can also do more like practical stuff. This won't be a stream like that. I'm going to talk a lot. I have to warn you. But also we have prizes. We have challenges. We have mini events in which we play a little and we hang out with the community. And well, this is great. Welcome you all. Probably preparing the last one right up to three. Yeah, exactly. Super hats. Sounds good. I join like 5 minutes when everyone says bye. Yeah, exactly. We have these in a row. Um, Actually, when this ends, there will be a time with no streams, but then we have a no light minigame. Then we have the machine learning with JavaScript part one and part two from UT. So check the agenda. You can check that on Global Hack Week or GHW.io slash agenda, I think. But if anyone can confirm, hi everyone. I am going to my friend's house after this. Nice. Hello. Hola. The nice. Hola. Remember, I am so rude. Again, sorry, I know there are several new people here. So my name is Alberto. I'm your friendly coach from Mexico. So that's why the hola it's really nice to me because it's Spanish. How to post on social media that we are participating in Global Hack Week? Are we any pre-developed posts from the Global Hack Week? I see many of them, so you can check on LinkedIn. You can type the hashtag Global Hack Week or MLH and check out what community is posting and get inspired by that. I see many people tag me on posts like that. For example, I remember one about. I think it was an artificial intelligence one, and these people post about a stream I gave about MATLAB and how to use that. And I'm going to repeat that stream this global hack week. So stay tuned for that. It will be my next stream. But yeah, get inspired by the community posts in LinkedIn. But on an official one from the Mayo League, I think we don't. So I don't know. When does the ML presentation starts right now. We are were the other streams before this important? I just found out this one. Yeah, of course, they all are important. So, previous one was the AI vector search powering the modern one, and supercharge your student journey with AI using pieces, both from Rosendo. And don't worry if you miss them, you can always check them on the recordings on YouTube or Twitch. I think it should start any minute now. Yeah, we're starting. Now it was sponsored programs. No, but they were really cool. I'm sure of that. Anyone who began completely the challenge, thanks for the info. All good at fine. Hey, Alberto, Green Jashik says, good to see you. Thanks. Uh, is there echo? I don't know. Is Road to Cage the only one who has echo, or do you have echo too? Let me know here in the comments, and I can, well, I can try to switch my mic, or I don't know, turn it up and off again. Uh, Maybe. Hello, Disarm. Agnil, nice to see you, Alberto. Oh, we're getting where we started. Pachuca Pachanga, yes, you look and see amazing, cool. Yup, the video and audio is good, cool, cool, amazing. Hello, Sparky Circus student. Great to have you back. Listen, B, hello. I hope to get familiar with so many names this Global Hack Week. So I see Blossom B, Apollo Naim, um, Krishna says hola for with these great MLH and dinosaurs. Hello everyone. Hi everyone. Hi. And again, thanks for posting. That's why I'm taking this time to see all your comments. Hello, how are you doing, sir? I'm just fine, thank you. First, MLH. This cool thing. What's that? I thought from afar that it was the Golang mascot, but I don't think it is. Same here. Are we going to cover only theoretical part, not mathematical? Yeah, no, not mathematical. Only the abstract context of what machine learning is. Um, Very lost on where the challenges are. I can only find the live streams. Oh, there's a dedicated part for this. I will try to find it. And well, give me a second. Okay, if you go to this page, you can find all info you should need for these global hack weeks. So this is the page, ghw.mlh.io, right? Oh, exactly. As slash challenges, there is the specific part for challenge. On their YouTube channel, hi, Shrut tips. It's hard to pronounce, but hello. Recommend you join the MLH Discord server too. Yeah, it is very important. There you can find all the incoming stuff. You can chat and discuss with the community and give us all your questions. If anyone is not on the Discord server yet, stop all you're doing. I'm going to give you 2 minutes to go and join the server and come back. No worries. I will talk. But go, really. Um, where I can find the other streams before this on the recordings on the. For example, I see you're on Twitch, so they are already recorded and ready to watch. The MLH YouTube channel too. Also, you can check the YouTube channel and there are the recorder. Hi, thank you. Where are the challenges? We covered this. Thanks again, Circuit Sparky Circuit student. As it's ghw.mlh.io/challenges. Uh, a bit no echo. Okay, I don't know what this a bit is, but I will take the no echo. Fact channel underscore server. Yes, amazing. I don't have echo here. It sounds okay. Okay, I think the audio is good. Look here, I get that when I have two tabs open on Twitch at the same time. Maybe if you have two tabs open, try closing one. Let's build something awesome. Yes, I'm very excited for this session. Super interesting. The subject material. Already excited. Woo! It's like Windows XP. Okay. Oh, okay, I get it. So it's Shruti XP. Okay, now thank you. It's submitting small challenges, not technical work. It's gonna be fire. Thanks. This is my first time joining MLH Global Hack Week, so I don't need to learn. So do I need to learn anything? You don't need to, but you will. I hope. What I do recommend you to do is. Check in this link so you will win community points, right? And do the challenges and participate in every session you can. That would be the best advice I could give you, and have fun. uh, okay, so lots of comments, and that's no complaint. I mean, I really love when you post all your comments here. But let's get this started, right? First, let me tell you what I wanted to do this session. Why I want this to be a theoretical introduction to ML. I don't know how many of you have experience with AI stuff, but I don't mean like the AI, like, oh, I use ChatGPT, of course. No, I use Tome app, so I create slides with artificial intelligence, or I use Stable Diffusion, so I can create images just from text, or my camera has AI, so I don't have to worry about looking ugly, right? No, no, no. I'm talking about serious stuff about AI. Like, have you ever developed your own AI applications? How you do them? What AI is actually, because we heard this so much nowadays that there's AI in the soup, right? AI in your conflicts, AI in everything, AI in the bread, uh, and there's no joke. Actually, there are tons of projects if you Google AI in the bread. Um, I see a comment here, no experience at all, and another one says, "Are these sessions recorded?" Yes, and you can always watch the recording from the previous ones on YouTube, and for this one, once it's done, also in YouTube. But continuing, the AI term has become more of a marketing term, right? Actually, as a joke before. Now we are doing AI, but when I started to work where I'm working, which is called Bigo, the marketing team post an announcement like, "Hey, we are using AI for tracking." Things, and I as a developer team, as was saying, like, hey, I am not aware of what we are doing, because I know we are not using AI for this stuff, right? But they don't care. They say, hey, we need to say we're using AI because it's cool. Um, Nowadays, we're using AI for many of our stuff, um, but again, it has become more of a marketing thing. Uh, Not really a thing companies are using, right? Not in the proper ways, or they don't fully understand what it is. And That's the reason I want to give this session for explaining what artificial intelligence is, and the most exciting, well, for me at least, the most exciting part of artificial intelligence, which is machine learning. We are going to understand what are the difference between these two, and another concept that it's in the air, which is deep learning, for example. What's the difference between these three? Um, can someone share the YouTube channel link over here? Yes, please. And I'm still going to talk. Um, and well, what are the difference, or what are the types or the classification of machine learning algorithms, right? Um, how they can be applied, why choose one or another, etc., etc. So, the intention of this session is to give you a picture of what the panorama is right now, nowadays. Um, and this is a spoiler for the conclusion, but we have to have in mind that machine learning, it's not the future. Machine learning is happening right now, and it's on our faces, and we need to take action in this. We need to start learning it from yesterday, because again, it's not the future, it's now. The future, it's something very interesting, but it is not machine learning. It is, mm, well, not even LLMs, for example, that are so popular right now. But I don't want to spoil you. We're going to discuss this at the end of the session. Right now, I'm going to start presenting my screen. So, what? Okay, yeah, here it is. Oop, let me move myself. Okay. Hi. Okay, I'm going to be this side. If you can see the text, it's my fault. I'm so sorry. I forgot that I needed to make this bigger. But I think it's if you put attention on the screen, I wanted to try a tool which is called presentations.ai, which I found very very cool, because it allows you to create slides using artificial intelligence. It's like a chat GPT for slides. That's how they call themselves, right? Um, and again, it's cool for quick stuff, but the turn down is that you cannot download the slide in any format, not even PDF. It has to live on their page. If you want to download the the presentation, you have to pay, or they sell you the pptx file, which is like what. And the editor online, it's awful. They don't allow you to make the text bigger, or zoom, or move the layout. um, that's what I didn't like. What I do like is, I like start getting the prompts from an interface before. Once you have all your prompts, you rearrange the data. You can edit what is going to be inside the slides. You can ask the model to include a specific type of data, like, hey, give me the definition of this, insert a part or a slide where you add this images showing A, B, and C. I don't know, this kind of stuff. So if you want to try it out, it was a good recommendation that I also tried for this session. Well, this is the introduction to machine learning. We all go to on leveling the core concepts and significance of machine learning through theoretical foundations, which is a fancy way of saying that we are going to explain what this is about, right? So first, I want you to understand what artificial intelligence is. Artificial intelligence, also known as the very popular AI, um, refers to system that wants to perform tasks that are typically required by human intelligence. So, trying to replicate this human intelligence, um, this human intelligence or any intelligence at all, are the main field of artificial intelligence. This task includes learning, reasoning, problem solving, understanding natural language, recapitulating patterns, and making decisions. Uh, in other terms, what artificial intelligence refers to, or the whole field is, it's how we think in computer terms. For example, visual, how to say it? Computer vision. Yeah. How we see, it's a thing, but how a computer sees is another thing. These two fields are not the same, but at some point they intersect. Because we say, if we try the computer to do all the things we do as we do them, it can be dangerous and, well, not dangerous, but it can be not as performative, right? Because computers only think in ones and zeros, but us can think in many other ways. So we're not sure. We, for example, I as a software engineer, I'm not sure how an eye work, but I know how a camera works. And I know how that camera passes the information to the computer. And I know how the computer is going to take analysis on this picture and try to interpret what is on the picture, right? So for years of learning, I, as the culmination of intelligence, discovered that a puppy is a puppy and a cat is a cat because I know the difference, right? But how you explain that to a computer? Well, trying to do these algorithms to identify patterns to say like, okay, set of pixels forming these, uh, how to say, this form, like in a triangular way, probably tells you that this is a cat. But there are dogs that has triangular, how to say, ears, right? So we cannot be sure of that. What else? Okay, if the pattern is a straight line in the eye, it is a cat because cats has this, I don't know the name of this, but this special type of eye that is one line, and the dogs have a circle, right? Same as us. Um Maybe that it's how we can start saying the computer, but it is thinking like us, trying to find these patterns, trying to understand what's happening. So that could be an artificial intelligence approach to this human problem, right? So emulating intelligence at all, it's the whole field of artificial intelligence. Now, we need to go one step inside, and this is the other thing I wanted to show you. This Venn diagram, artificial intelligence is the whole set. Machine learning, it's a subset of artificial intelligence. And deep learning, it's a subset of this machine learning, right? So now that you have this mental model, this mental picture in your minds, I want you to take a step behind and see that machine learning, it's this subset of AI. These abbreviations are cool. Machine learning, ML, artificial intelligence, AI. You need to learn this slang that focus on developing algorithms and statistical models that allow computers to learn and make decisions based on data. That's the main difference. So, artificial intelligence is the whole system. This tries to emulate intelligence at all, and that specific part of intelligence that learns, it's the subset of machine learning. Now, these machine learning algorithms try to learn, and you can think this of this as I won't show you how to do a task, but I will tell you if the task is well done or no, right? So this is unsupervised learning. And these two subsets of this are the different parts of what machine learning has. Machine learning has a subset for unsupervised learning, a subset for supervised learning, and there are another one from old days that's called reinforced learning. And we can consider now a fourth one, which is called semi-supervised learning. I don't include them in this session because it's not that studied, so I won't be able to explain it to you because I don't fully understand it. But have in mind that there are fourth one nowadays that it's called semi-supervised learning, right? So before explaining these subsets, I wanted to include another part of the machine learning, which is the deep learning, right? What was the third one? Don't worry, there are slides for this. But okay, first, there is no order, but you can think of first, it's supervised, second, unsupervised, third, the reinforcement learning, and the fourth one it's semi-supervised, right? Again, this semi-supervised, there are no more, well, this is like new between quotes, so they are doing like a lot of research on this, but there's no good documentation this far. But before taking these sections of machine learning, these types of machine learning, we talk about another subset, right? Which is the deep learning. What is this deep learning? This deep learning are the one that you probably heard with neurons, with how to call it, neural networks. Does that mean that neural networks refers to deep learning? No, actually, neural networks can be used in machine learning outside deep learning. But, for example, in a machine learning scenario for classification, imagine that you can give an apple or an orange to the network. With traditional machine learning, you used to give these two inputs, but you have to define the classes, right? So Apple has uh, uh, how to say, a different shape from the orange. So you define shape. The apple has a different color from the orange, so you define color. Let's think of this as apples have a different texture from the orange, so you define texture. With traditional machine learning, you used to give the inputs and hope for an output to be the one you want. You establish the output could be orange, or the output could be the output could be apple. Well, in deep learning, you don't need to specify the inputs, not as values. No, you don't say color, you don't say texture, you don't say shape, for example. You just pass the data. And deep learning, it's called deep because it has more more complexity in the I forgot the name of this. I have to say, there's a name, but you can think of in the layer of the abstraction. And once the process is done, the output will be the apple or the orange, even that you didn't specify the input. You didn't say this is going to be an apple, this is going to be an orange, and orange are recognizable thanks for the orange color, thanks for the uh, skin pores, thanks to the round shape. No, you just pass the info, right? So deep learning, it's the subset of the machine learning that focus on using artificial intelligence neural networks to deeply process these complex tasks. And unlike these traditional machine learning models, they rely of feature extraction. So these deep learning models automatically can learn how to extract these relevant features from the data thanks to the multiple layers of the processing. So this says also layers, but I know there's a specific word for this. Uh, we can give a neural network class in the future. How? Let me check the comments. Where does hybrid comes in? I think you're referring to this semi-supervised, right? Or what you mean? How does semi-supervised learning address the issue of bias labels in training data? Actually, that's a good question that I cannot respond to that because I'm not sure. My guess are that well, they do this for a reason, right? The issue of bias labels in training data, it is because returning to the example, we have to label things, and we as humans have a whole history trying to learn this. And there are simple ways, or there are simple things to label, right? For example, I can say to you, if I show you an apple or an orange, or a picture of an apple or a picture of an orange, to be more accurate, you can easily label them as humans, right? But if I show you a picture of someone smiling, and I want you to label it with an emotion tag, that will be more complex, isn't it? Because it is subjective. Someone can be smiling like this, and someone can be smiling like this, right? I'm going to put big my face. So again, someone can be smiling like this, and someone can be smiling like this. This is my smile. So the bias on labels in the data, there's more than a machine learning problem. It's a human problem. So semi-supervised takes the, how to say, no, for answering this, I first need to explain what is supervised and unsupervised, right? So let's go to that. Should 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 the XP? Thanks for your question. I'm going to return to that in a minute, but let's continue with this flow. So in machine learning, we have to extract the features manually, but with deep learning, the natural networks extract the feature for us. Exactly, that's the whole idea behind this. How will deep learning then be a subset of machine learning? Again, machine learning, the idea of artificial intelligence is to emulate intelligence, right? The idea of machine learning is to take the specific part of intelligence that learns. So this learning can be done using several ways. Uh, tables of data, algorithms, neural networks. And a specific set of this machine learning, it's trying to use these neural networks not to learn from what we tell them to learn, to learn at all. Uh, and having a multiple number of layers of a neural network can extract data. And again, it is a human bias. Think of how can I recognize um, an apple? Well, I know apples are this shape. Apples have this flavor. Well, it is that a computer cannot taste the flavor of an apple. Apples have this texture. How can I recognize an orange? Well, orange has this color. Orange has these shapes, etc. But that's how we recognize them. What if, for a computer, it's simpler to say orange oranges have this shadow for saying something absurd, right? But what I mean is they don't need us to tell the how to say the relevant features of a thing. They try to find the relevant features of what we are passing. A good moment for saying something right now is there's a common say in artificial intelligence that is garbage in, garbage out. That means if we pass garbage data to our model, it's going to return us garbage at the output, right? So we need to be sure we are passing good stuff, good pictures, quality images, um, a good diversity of images, because if we pass the same image 1,000 times, it is garbage, right? So uh, that's how this deep learning, it's the subset of the machine learning. It uses the core concept of machine learning and focus them on a way to solve a problem. Question: in deep learning, do we have to provide dataset manually, like in ML, or can model generate new data and make prediction? It depends on the type. Remember, deep learning it's a subset of machine learning, so we can also give supervised, and reinforced. And getting to the team, the problem of supervised and unsupervised learning is that you require tons of data. An advantage of reinforcement learning is that you do not require that much of data, you know? And to answer shortly, the answer will be yes, we need to pass the data. They cannot generate it. But we can reduce the amount of data based on the technique we are using. Talking about this data, in general terms, and we are going to get on that, one of the biggest problems of artificial intelligence is that it's that we require data. We require uh, lots of things to learn, and even with the techniques we talk about reinforcement learning and how we can reduce them, there are other techniques. Uh, to for example, if you have an image, you can rotate it a little. You can change the colors a little. You can use a filter or a mask to make them similar but not but not the same, like slightly different. You can manipulate your data. For example, if you have a set of 100 pictures, which is nothing, you can use these techniques to make them 1,000, for example. But there are how to say it, not organic data. You create them, right? And that's the problem, for example, of GPT when it was released. And they were saying GPT-3 was based on the on all the information in the internet, etc. And someone accurately said the problem is that when GPT-4 comes out, well, they do a lot of things for this not to happen. But uh, at first, they say when GPT-4 comes out, it will be trained with internet data again. But the problem is that 60% of the internet data will be GPT's data, right? So it will be fitted with their own prompts, with their own outputs. So that loop, that retroalimentation loop, will give errors and will be biased and will be um, have, bad data to train the model again. So in general terms, generate data with a model, uh, sometimes it's not that thing we want to do. Uh, there are specific areas of artificial intelligence dedicated to that, because in other cases it's something very very suitable and very very good to have. But in most cases, we want organic data, or data that is generated from humans, from the things we want to do, actually, not from computers. I think because we are still training a big computer from data to data. Okay, question. Also, okay, this is another question. Also, in deep learning, does the natural network only extract the feature for us, or does it also extract what the object is? For example, an apple. Uh, this is a great question. The answer is no. It does not extract the feature for us. Actually, it does not tell us what it's happening. These deep networks, actually, these neural networks are black boxes. And there is a specific field of research that it's trying to say these should not be black boxes. These should be more understandable things for us as humans. So there's a specific field in this artificial intelligence stuff that tries to, and there's a word for that, but I'm forgetting it, tries to make this more transparent, tries to explain what's happening. For example, uh, if we run this on the example of the apple and orange, their neural network is not going to say to us, "Oh, I learned how to identify that these images has an orange color. These other images had imagine these are golden apples. So these other images had a yellow color. They don't say that to us, and it is not magical. They don't. They are not labeled like that. They are not labeled with natural language yellow and orange. Uh, we need to inspect the outputs of the layer to say, oh, okay, I think that in this layer the neural network started to recognize the colors. I think that in this other layer, at this point, the neural network started to recognize the shape. And again, there are some scenarios that for us as humans, the output could not make sense at all. Um, we can imagine that it is a hidden feature of the images. I don't know, maybe light conditions, maybe perspective of how the pictures were taken. For example, imagine this data set will build in 2 different days. So the oranges images had a specific light condition because it was a sunny day, and the apple images have another light condition because it was a rainy day. So it changed a lot, and the neural network learned how to identify that. And even it was a thing that escaped from us as the ones who made the data set, and even the ones who to create the model, etc. So no, we don't know what they're learning, what they are, how they are extracting these features. But there are techniques, and again, there's a specific field that's making or trying to make that more crystal clear for us. So I hope that answers the question. In what scenarios would integrate deep learning with traditional machine learning techniques provides a synergistic advance? Actually, I think I don't fully understand this question because remember, for example, saying you're doing deep learning means you're using artificial intelligence, right? Because it's a subset. So in all scenarios, you are applying deep learning, you are applying machine learning, um, and that's it. So if the question is, in what scenarios will integrating deep learning with traditional machine learning techniques provide a synergistic advance? The answer will be in all of them, because there are no separate sets. The deep learning is a subset of machine learning. So in all cases, you're using deep learning, you're using machine learning. In all cases, you're using machine learning, you're using artificial intelligence. So the synergy is there. Uh, Hope that answered the questions. And okay, I think we're ready to continue. Again, I really love see all your comments here because they'll tell me you are understanding what I'm doing, what I'm saying, right? If I didn't answer a question correctly, or you still have the question, I wasn't clear. I mean, please tell me. And I will try to do my best effort again to answer it. I know I still have this in like to say, uh, I still need to answer this, but I first need to explain the three more the three continuous slides to answer this. What do you think is the more powerful language for the next 5 years? Okay, it's simple. JavaScript. No, no, no. Well, I really love JavaScript, but in terms of powerful, I don't know. Like it fully depends. JavaScript will be the web language always. Well, I don't want to say always, but the a strong language in web all the time. It can be used for robotics, it can be used for server side, for client side, it can be used for IoT, it can be used for artificial intelligence, for cloud, for a lot of things. I mean, that's why I love JavaScript. Uh, but also Python. I mean, Python is very flexible. There are specific languages for specific cases. So again, it doesn't matter. These questions, Gabriel, don't worry about learning a language. The matter of learning the language is ask yourselves, what do I want to do? And that will answer the question. Then you need to learn this. For example, you say, I want to be a mobile developer for iOS. There's no alternative. You need to learn Swift. It doesn't matter if you want to learn Ruby, or if you want to learn, I don't know, Dart. Uh, you will need to make Swift, right? So if the question is, I want to make web, well, you can do it with Python. I mean, it's okay, but the main language is JavaScript. If you say, I want to do artificial intelligence, for example, I will encourage you to learn R and Python. Which is simpler? Python. R, it's more difficult, to be honest. But another thing I want to say is that learning programming language doesn't mean you know how to program. Learning how to program, it's not vinculated to learn a programming language. Learning a programming language, it's knowing the syntax, knowing how the language works, what the advantages of using that language is, like the fundamentals. But knowing how to program, it's knowing how to communicate to a computer via algorithms, via instructions, via etc. Right? So that's the main thing here. How do you manage JavaScript asynchronous code effectively? Whew. It depends. It depends completely on the scenario. Like, if you can use promises, you can use async await, you can use callbacks, you can use now with reactive, RxJS, you can use observables. Uh, but I mean, that's what I always say when I give this type of classes. Uh, they are in the language for a reason, right? So it doesn't mean that, for example, first they will callbacks, but the callback hell was a hell, so they introduced promises. But in some cases, promising was uh, that tedious, so they introduced async await, which is syntactic sugar. Now people are trying to make observable part of the core language, not just uh, part of the reactive library. But again, they all are in the language for a reason. Learn how to use them, learn where one apply better than the other, and that's the answer. Well, thank you for answering. I work in data engineering. That's really cool. Makes sense. Thank you. For that, I also recommend you not only to study languages but architecture and algorithms that will make you better data engineer. Do you recommend using Codelight for C? Actually, I'm not that of a user of C. I sometimes use C plus plus for video games, but I'm not that familiar with the whole C environment. So I don't want to lie to you. So I don't know the answer for this. Uh, what I'm just using. Okay, I think I missed this. Sorry. What are the advantages of using deep learning versus traditional machine learning? I will say the how to say it, the feature extraction. So again, if it is something that we as humans can do very well, like identifying an apple from an orange, maybe the feature extraction is not that bad, right? It is simple. And it will be an overkill to use a deep neural network for doing that. But again, returning to an example of trying to identify emotion in faces, it's more complex than that. Many of us are not sure how to say, oh, I know that people or that person face is angry because I feel it. But you cannot program an I feel it sentence, right? Computers can't feel. So the deep learning scenario will be better when the feature extraction it is difficult even for you as human. That would say. Do you recommend? Okay, no. Do you have a language you recommend for desktop applications? Uh, uh, well, I think Java could be the best. But if you ask me, I would say that JavaScript with the use of Electron is also good. But yeah, Java and C also. It depends what you want to do, and if you want it to be like a Windows XP app or a modern app. Is machine learning with Java possible? Of course it is, thanks to TensorFlow JS. And also remember, these libraries help us to avoid conflict creating all from scratch. Like, for example, if we want to create a machine learning application that uses a neural network, not a deep learning, but a simpler one that just have 3 or 4 layers to identify, I don't know, a zero from a one, or to perform an addition. That's possible. Again, it's an overkill, but that's possible. If we want to do it from scratch, we need to program a lot of things, how the perception layer communicates, how a neuron is, what the activation function is, blah 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 blah. But it's possible in not only JavaScript but in many languages. It's more possible in JavaScript thanks to the use of these libraries. It is even more possible in Python thanks for uh, TensorFlow and for PyTorch, which is really really great. And for what I heard, it's now more capable than TensorFlow and many other libraries. But it's possible to do machine learning with a lot of languages. The thing is, the one with the good libraries are Python and R. Why R, especially for machine learning, beside Python, why they make it so pure powerful? To be honest, I don't know. I only use R one time for it was for creating smart contracts. I don't know what makes R so powerful. I know it is complex. It is more complex, but I know it is a good language for machine learning because a lot of these libraries that has support for Python also have for R. Oh, sorry, I was choking, so I needed a break. Last question. You mentioned something about the future at the beginning. How do you see future in 5 years? What do you recommend to learn? Again, really, really nice question. But I'm going to save this for the last. Uh, so don't hurry. Just to be clear, you're doing QR right now. No, actually, no. I was just giving the presentation, but I like to answer the question when it appears. So we will have a QR at the end of the session, but it's really nice to have all your questions. You ever tried something like Haskell for AI? No, to be honest, I only tried Python and JavaScript for AI specifically. For all the languages at all, I haven't tried Haskell, but I have tried C, I have tried Java, I have tried Python, JavaScript, and a little bit of Flutter. Just curious, how long is this session? Most of the sessions are 2 hours. It depends on the content. Um, Sometimes it's fewer, like an hour and a half, uh, but mainly hour and a half, 2 hours. It's the average. Thank you. This was a good primer to AI. No, thanks to you. But we're on the half of this. Thank you, Alberto. Don't worry. But again, we are half the way. We need to explain the supervise and stuff. What's the best way to start machine learning? Um, okay, that's a great question. I will say read read a lot because not like other fields of programming uh, need that much of a background. I mean, for example, I started doing web because I think web was really easy. And yes, I know there are complex things in web, and I know we need to learn and do a lot of things, front and back and DevOps, blah blah blah. But you need a lot of context to understand machine learning. And again, programming a model for machine learning is not that hard once you understand the abstraction of it, because that's the hard thing, the abstraction. The libraries and all the stuff that it's already prepared and made for you to apply the model, that's simpler. Like it's like calling functions. It's like setting a piece of Lego. I don't know, like putting together all the bricks. Having data, it's one of the biggest complicated parts. But understanding the thing you're doing, that's the whole problem of AI. What to choose between JavaScript and Python in terms of application, which has broader applications or scope? Uh, for me, JavaScript. But again, it depends what you want to do. If you want to focus more for data, then I have to be realistic and I will say Python. If you want to make more things for the web, for robotics, well, for robotics, it can be Python too, to be honest. But again, if web it's on your mind, take JavaScript, and JavaScript has a scope for any other thing. But if you want to focus on data in general terms, Python. What's the best way to start? Mel, I already answered this. Thank you. Can you please share any resources to learn more about feature extraction? Ooh, I'm thinking of them. Uh, Let me see. You know, I don't have them on my hand right now. I will have to do some research for this to make a list. But let me know on Discord. Tag me or something. What's the best resource to learn AI ML from? Again, I think the books. These There's a series called Introduction to AI ML actually from O'Reilly that you can check out. In math specifically, linear algebra or calculus and they are really necessary to learn AI ML. Yeah, you need a mathematical background, but I mean, I will say there are two types of developers in the world. The ones with the mathematical background because they studied it like computer science at school or their majors, and the ones that pivot from other fields like I don't know uh, accounting, like they used to do a lot of things in their lives and they pivot to programming, and both are capable to do this. But the ones with the mathematical background will have these like already covered, and the ones with not, yeah, they need to learn calculus, linear algebra, but mainly they need to have a mathematical way of computing. Like you need to think in terms of algorithms, and that's it. Because algorithms are already writing for this artificial intelligence stuff, and you not just need to try them, to apply them, to fit them to your needs as well as you develop artificial intelligence. It is not true that you will develop a new artificial intelligence algorithm that will solve all artificial intelligence problems. No, algorithms are already there. Neural networks are already there. Uh, Knowing how to apply them, knowing how to struct your neural network, what information to give, what how to say what parameters change. That's the fine art of this. But mathematicians, sorry, are the ones who have to worry about this. And if you want to do that, like at the beginning, I thought like, wow, how can I program an artificial intelligence that will be uh, too much math? Well, good good thing or bad thing, it depends of your perspective. It's that you don't, you just need to follow like instructions like recipes, right? So if you want to do that, I will advise you to focus more on mathematics than in computer science. uh, what should you read? Let me look for the book I'm saying, and that will be a good start. Give me a second. Also, I need a break to sneeze. Oh, okay. I don't know. I was good all day, but now I need to sneeze all the times. It's one with a lizard on the cover. Let me see if I can. Okay, this could be a good one. Introduction to machine learning with Python, but also there's another one. Oh, this one, the cookbook for more, how to say it, um, practical way to learn. This one, machine learning with Python cookbook. They are really great. So returning, uh, I think we now are ready to continue because all questions are. Oh yeah, exactly. Thanks. No, no, the ones I shared. We have this. I find Khan Academy a really source if you're trying to study linear algebra or calculus. Yeah, thanks. Thanks for sharing that. So, I need to remove myself. Machine learning for uh, how to apply it. What are the different types of this? The types of learning, supervised learning. In supervised learning, we need to find patterns based on the data and look for a prediction, right? So explore, no, sorry, involves taking this label data to know how or what we are going to predict when it comes out. That means for supervised learning, these 4 years was the main paradigm. It's very similar to the Apple example. I mean, not all classification examples require a neural network, and I want you to take that out of your mind. For example, there's something called the key means algorithm that is a way in how we learn. And it's applied and it's part of the machine learning set, and it's not neural network. It is just an algorithm that maps a space and says, for example, if you give me an apple in a chart, I will position it based on the features that you give me of the entrance. And if you give me an orange, I will do the same. Once you give me enough data, and in this case, I will say that another concept that is very important, which is give me a second. Oh well, I have a note here. I need to return. Give me a second. I lost the note. Oh, ho, ho, ho. Mm. Ah, yeah, partition. So yeah, again, sorry for the distraction. I lost the track of this. Supervised learning needs the data, but this data needs to be partitioned. What does that mean? A partition is for those with this mathematical background we're talking. You know this, but for those who know, it's a special case of sets. For example, in this example of the artificial intelligence, the whole set is artificial intelligence. The subset is machine learning, and the other subset is deep learning. Now, a partition, um, it's a specific case in which none of the okay, I can find a good image here. I need to take a screenshot of my notes then. Okay, a partition is a set in which none of the subsets are in the other. What does that mean? It means this one. Let me open. Well, I need to stop sharing this and present again about another camera. To make this more interactive. Okay, this. This is the set, the whole universe. And what a partition is, for example, we have a, a subset 0, 1, and 2 that has no equal values that are part of these subsets. What is not a partition, it's, for example, the AI example. Sorry, in which the whole universe, this set, in this case represented by the C3, will be artificial intelligence. But, for example, C2 and C1 could be another terms that has same values together that intersects at some point. But also C1 and C2 are have values of C3. This is not a partition. Partition needs specifically to be C0, C1, and C2 with no values that are the same or that intersects with the other subparts, right? Now, once that this is clear, let me return to the slides. Nice. Now that this is clear, there is a pipeline for doing this supervised learning, right? First, we need to gather data, and that's almost for every type of machine learning. We need to gather data. We need to make this partition, and we cannot separate them equally. It depends on the validation method we are going to use. Validation methods are multiple, and a very common one is the K-Frost validation. Another common one is the holdout validation. A holdout validation can say we need to set a train subset, a validation subset, and a test subset. Normally, the train subset will be like 60% of the whole universe. The validation subset can be 20%, and the test subset will be the other 20%. So we have 100% of our data. These validations determine if our model is a success or not. So it's very important. For example, in this holdout model, we take the data, we train our model with the validation, sorry, with the training, then we validate and we test, right? Why these different three? Well, we need a part of the data for training that I think there's no questioning that, but why a validate and why a train? Well, sorry, why a validate and why a test? The validation data can also interfere in the training of our model. The validation data serve us to not wait until all training data is done, but for example, to take epochs to say, okay, we want to train our model with how many data and in how many epochs, and that means dividing or training data in batches, right? And for example, if training one batch takes 10 minutes, that's a lot of time, right? I don't want to wait until 10 times 10, 10, 10 times 10 minutes to validate. And I want to see the progress. So I divide these batches and I divide the same amount of batches with my validation data. So at the end of each training batch, I validate. That's why it can interfere with the process of training. And how I validate says, okay, this has a percentage of accuracy of 1% at the first batch, which is totally bad. It is super bad, right? But with every batch, it is increasing, which means our model is learning, and that's very good. And we validate that using the partition of validation. Now, at the end of the training, we know, thanks to the validation partition, that our model has an accuracy of 80%. That it's quite good. So we need to test it. And we need the model to see images, for example, in this case, if there are images, that it has no, that the model has in view in all the time, not in the training, not in validation. So we can test and hope to the output to be the same as we expect. I mean, a probability of 80% to the model to predict correctly or to classify correctly, right? So that's the whole idea here. Uh, an example of this, give me a second. Sure, sure, sure. Oh, Uh, an example could be using the Keyman's model. Again, it's not a neural network, but it tells which of these are closer to their network, their networks, key nearest networks. It's the meaning of that. So what the algorithm does, it says, okay, you pass me this data. Remember, we are on supervised learning, so all the data it's labeled. I put it in a location. It can be 2D, 3D, 4D, 5D, depend on the amount of data and the types you want to classify. But imagine it's a 2D. So again, apples and oranges. I put it nearest to the apples axis, and then you pass me another data, which is nearest to the oranges axis. I am being trained because I know the result of these images, right? Again, I'm trained with lots of data, lots of data, lots of data, lots of data. Then I validate, and then in the testing, I, for example, pass an image that the model hasn't viewed at all time, and it is placed somewhere between these two axes. And the model asks itself, what elements are closer to this? Typically, we choose a number, an n, that it's uneven. So they will have a most, how to say it, identification with a part, right? So let's think of three neighbors. So imagine this image, it's placed just in the middle. It takes a neighbor that it's an apple, but it takes another two neighbors that are oranges. That means this thing is closer to be an orange. So that's why it's an orange. Okay, we classify with this model. Now, a warning with this. We only hope for a classification with two things. We didn't say this could be apple, an orange, or undefined, or I don't know. No, a funny thing about this is, for example, if you pass an image of your face, you will have a prediction of what you look like, an apple or an orange, because the algorithm is going to take the nearest neighbors. So I don't know what your fate is going to be placed, but the output should be apple or orange, and you will discover what you look most like an apple or like an orange. That could be a very funny thing. For example, if you have a prediction percentage accuracy of 100%, you can make an app with this that tells you what you look like, an apple or an orange. But that's probably not the intention of your app, right? So just a thing to be warned about. But I think with all of this, the supervised learning makes sense, right? So it's supervised because we pass labeled data. We know the output when we train it, and we verified with again labeled data. The next one, it's unsupervised learning. Unsupervised learning involves training models that are not labeled. Sorry, with data that it's not labeled. And what we want to achieve this, or why we want that, is to find patterns that are not instinctive to us. Is there a way can we get these slides later? Let me look if I can share them because again, I mentioned at the beginning I cannot download the PDF or anything because they want to charge me like for life. But let me see if I can share the link or something. Thanks. So it's very similar to the question I asked. I answered before, like where deep neural networks make sense. Well, they make sense when probably we don't. There's no easy for us to extract the features, and it can be easier for the network to extract the features. Well, same happens here. Labeling, it's not the same as feature extraction, but labeling, it's something great when the task is already mastered by the humans. But it's something that it's not mastered by humans yet, can be very hard. And this is where supervised learning can come handy. This thing of not finding patterns, or sorry, of not having labels, will give the model ways to find invisible patterns, well, invisible for us at least, and we can learn a lot of that. And I think one of the greatest or most exciting parts of machine learning are these ones, unsupervised learning. For example, if you want to use this not for classification but for clustering, what does that mean? Classifications means it's A or it's B, right? So uh, classifications means you want to be this part of this part. Clustering means how we can group data, how we can group images, how we can group, I don't know, sets of data. Clustering, it's an interesting thing for unsupervised learning because we can start throwing data. Again, remember, garbage in, garbage out. We need to throw good data. So we can start throwing good data to these models and start to see how they uh, cluster things together. For example, these apple and oranges example I'll be giving the whole session. Imagine we add another one. Imagine we give uh, uh, a banana. And for a reason, the unsupervised model starts clustering together the banana and the apple because both are yellow, right? We can start finding what structures make that possible. But think of it as another way of how we can, as humans, reinterpret how we make things. Because for mathematics, we know that an addition is that we combine two elements and give us another. For a computer, it's like having a baby, like you don't know what to expect in this unsupervised learning, and I just think it is exciting. um I mentioned here that this includes clustering, uh, because of the similarities, the association, the identifying relations between the variables, right? Here, I make an example of the segmentation based on purchase behaviors, and this is a great example. Once I heard, I think it was on Target, the store. If you know what I am talking about, there's in the US there's a store called Target that use an unsupervised model of machine learning to to segmentate their customers. And this model was so good that one person started, well, a girl started receiving ads from Target because she was tagged as a pregnant woman, and she didn't even knew she was pregnant. But based on their consumption habits, the model tagged her as pregnant, and months later, she realized she was pregnant. So it was not the purpose of it, you know. The purpose of the network was to segmentate customers for them to sell them more. But the model was somehow that accurate that the model even know that a woman was pregnant. That even with just the consumption habits, I think that's just mind blowing. Uh, but yeah, with this, I think unsupervised learning it's clear, right? And the final, oh, which is reinforced learning. This is very simple, and I think it's very intuitive. This is how we learn as humans. Actually, this concept was defined many years ago. This is not new at all. The problem was at the beginning, the computational requirement for this. It was very hard. Nowadays, it's still being very hard, but we have a lot of power in our hands, in your hands, if you're watching me in a smartphone in front of you on your computer. Now, this is possible thanks to that. But reinforcement learning, it's how animals learn, how we learn, because we are animals. It's your mother saying, don't do that, and giving you how to say, there's a word that I want. Well, a punch to say in a way. Now you don't want to receive a punch. Yeah, good analogy. Thanks. You don't want to receive a punch. So next time you won't do that. Or when you do something good and your parents say to you, "Great, I am going to buy you a present," or that the present could be a candy or something. So you receive a candy because you done your tasks. So the next time you will do your tasks again because you want to receive a candy. Same like rats with cheese, right? So you put a rat, you make them complete a algorithm. If they do complete it, cheese. If they do not complete them, I don't know. I don't want to say animal cruelty or something, but you get the idea, right? And this it's very good because, as I was mentioning, you don't need that much of data. You need to instruct scenarios. In the previous ones, supervised and unsupervised, you needed a lot of data. In supervised, tag data, which is more work. In unsupervised, even it is not tagged, but you still need data and data and data. In reinforcement learning, you just need to create scenarios and make iterations over that. For example, let's think of this maze game. If you put an AI inside a maze game and you define correctly, if you turn this direction, turn up, turn right, turn down, turn left, etc., and you reward like things like moving from a hall to another, like not facing a wall, like exploring, because another thing that can be done is that he goes just one direction, one side and another, because the algorithm doesn't wants to turn left, because he will be, well, no, I mean it will be punished. If you reward these kind of things, you probably end up with an algorithm can sorry a machine learning, an artificial intelligence that can solve not only that maze, but can solve mazes. And that's thanks to reinforcement learning. And you don't need that much of data. You just need to develop the whole idea here. And here are a key concept that I mentioned: exploration versus exploitation. That's the trade off. If you explore a lot, like in life, you probably find a way, and the next time you know that's the way. But you can say, hey, why not? I can go another way. And you probably lose. And you probably won't complete the maze in for example, if you're against the clock in the time, but you will complete it. In the other hand, if you explode, like uh, this concept is hard to me because it's in English, and I don't think it's a good translation for Spanish. But if you just go all the same way every time, you will face the same wall, you will face the same error, and if you don't explore other alternatives, you won't resolve it. So that's the trade-off. Sometimes you will want the algorithm to explore, but other times you will want it to be sure of it. And there's a fine line between that, and playing with that. That's the whole idea for reinforcement learning. An example is the how to play a game, and this is the same I mentioned, and we can make a comparison here for the chess, right? If you do supervised learning uh, about give me. Sorry, about chess, you probably will need thousands and thousands of hours of recordings or pictures for how that play, and probably will not be that good. Instead, if you do it with reinforced learning, you just need to put into play. Practice make perfect, right? So same as you as human, if you start playing chess one day, you probably won't be the best in every. Sorry, you won't be the best at the end of the day, because you need to play a lot. And once you play long enough, you could be good. Well, the thing with AI is that it can practice a lot, but a lot in fewer time. um, and specifically for chess and Go. I think it was an IBM machine. I, I don't want to lie, but I think it was Deep Blue, if I remember well. Someone can correct me here. That become the world champion in Go in 6 months. Can you become the world champion on Go? Probably not. But I can tell you, machines, not at this point, can't create games. We can. DeepMind. Oh, and then Deep Blue. What was Deep Blue? Ah, okay. Maybe Deep Blue was the one for chess. Thanks. Thank you. Uh, Another example in robotics, how to perform tasks, navigate, grab objects for industrial fabrics, etc. Self-driving cars, that's another thing. Reinforcement learning, it's another exciting thing to do too. The thing with reinforcement learning, all of the artificial intelligence, that's yes, blue was for chess. Oh, thank you. Yeah, the thing with machine learning and all of this stuff is that they have challenges. Here are more concepts about the reinforcement learning, but I'm going to skip them. Uh, and these challenges are the data quality and acquisition. We need a lot of data, and acquire those data. It's a big challenge for machine learning. The interpretability and transparency. The problem here again, and you asked for this, and you have that in mind. We don't know what is happening under hood. We need to start making explainability models for us to understand what's happening under the hood, for us to understand what machine learning is doing. We don't know this far yet, but we have some advances. Again, there's a whole field dedicated for that. Not the last, I just mentioned these three because I think these are like the complex, but there are a lot. The bias and ethical concerns. I think, in my personal opinion, that machine learning, artificial intelligence at all, it's a multiplier. It can multiply you. If you're a person that can program well, for example, and you use artificial intelligence as GitHub Copilot, you can be multiplied 100 times, and that's amazing. And you will do things that took you minutes, sorry, hours, in minutes, in seconds. If you're a zero, you will be multiplied by zero. The good stuff is going to be multiplied, but the bad stuff too. So this tool, it's dangerous not because of of its nature. It's dangerous for us, right? So again, remember, this is a multiplier. So human bias, human ethical, how to say it, like the bad we can do, the bad the artificial intelligence can do, and that's a heavy concern, because not as humans, not as single humans we are perfect, but the good thing about us is collaboration. So probably you has your individual opinion. You think of a specific point, and you have your bias and you have your contrast, and you can be wrong, but a group of people cannot be that wrong. So um, my opinion on how to solve this problem, specifically the bias one, it's to have groups of people, and I'm going to give more than that in that section. I just want to mention these ethical considerations concerns the bias and fairness, the data privacy, the explainability and transparency of the data, the human oversights, that how we can interaction and how we can remain uh, relevant in our own world, accountability, and well, the long-term impact, right? uh, Talking not about only the social but the environmental ways of machine learning. Future trends, just to wrap up this session, I think in the future we will see more general adversarial networks. That means general AI. um, these general adversarial networks are going to be a big part of the future. So if you haven't heard of the concepts, take it. It's GANs abbreviated. Uh, and the other thing I think we are going to see a lot is the trendy of low code and no code. Um, in general terms, what this says it's that most people will be available for artificial intelligence to create models and to deploy or make use of these technologies without having to know code. I mean, effortlessly. And I think that's a good thing because, in conclusion, the same what I mentioned to you at the beginning. The artificial intelligence is happening now. Machine learning is happening now, not in the future. And how we can take action in this is joining the discussion. Talk about this. Talk about ethical concerns. Talk about environmental problems with the machine learning. Be involved in those things. We need more hands. I mean, like more people doing this stuff. More people thinks better than lesser people. So that's are my conclusions here. I wanted to do a Q&A, but I think we don't have time for that now. But if you have any questions, just comment here. Thank you a lot for joining me for this session. I spent a really, really good time with you. I hope you do the same with me. Um, and I think you do because all the comments of all your questions. And I hope I give you a good introduction to what the current picture in machine learning is. I hope to solve many of your questions, but I also hope to give you more questions that you have at the beginning because that only means that you are learning. Uh, where are these competitions where you can be a champions in one language? Uh, Oh, I don't know. I don't know what you're talking about. Sorry. Like a language, for example, a programming language. You mean like I'm the master of JavaScript or, or something like that? I sorry. I think I haven't heard of them. Alberto, this might be a somewhat naive question, but I'm curious to hear your thoughts. You you likely seen Terminator. What is your scientific opinion on the future of AI? Do you believe we could be laying the groundwork for something akin to scale it? Thank you. To be honest, I don't think so. To be completely honest, I heard so many podcasts of people talking about this, and I don't know, like, I don't think they fully understand what they're talking about. Um, and in somehow at some point we reach that future. I don't think it will be for us, maybe our grandchild's, but I think we are far from that, but far from that. What I do think is we are close to this artificial intelligence, to these kind of tools. uh, in science fiction, like I will when I was younger, I liked to think artificial intelligence as the next step of evolution in human being, right? And I know that can sound crazy, but I think again we are far from that. We are in baby steps pointing to that maybe. But what we do have, it's a great, again, a great but great multiplier for the things we want or we can do as humankind. Uh, but yeah, with that thought, I close the session. Thank you a lot again for joining me. And I invite you to join me also on Monday for learning this not in a theoretical way, but do in a practical way using MATLAB. Then I will have the same on Wednesday, but not for MATLAB, for quick implementations of the AI in the web. And finally, an introduction to reinforcement learning on the next Thursday, I think. But yeah, check the agenda. And well, I hope to see you back again. Thank you so much. Thank you. Thank you. Thank you. It was a great session. Thanks. Thank you. Well, bye bye.